For 5.6, it is called the rational functions graphs. But here, instead of trying to graph rational functions, we want to understand how to find their vertical asymptote. And then we're going to also understand how to find their horizontal asymptote. And then we will also find their intercept. So here, even the homework questions, they don't ask for all of these things. I'm going to still explain all of these things for each question because the test might have a different question than what you see here. So identify the y-intercept of this rational function. Rational functions, they look like fractions. They will have a numerator and they will have a denominator. So their most important characteristics is they have a vertical asymptote. These are vertical straight lines that these functions are not supposed to touch. And then if they touch to the vertical asymptote, they become undefined. So vertical asymptotes, to find the vertical asymptotes, we will always look at the denominators. So, for example, for this question, in the denominator, the very nice thing about this question is denominator is already factored. So one factor is x plus 1. We need to see when this becomes a 0. And when x equals to a negative 1, if we use x equals negative 1 in this function, the denominator becomes 0. And then whenever the denominator is a 0 for rational functions, the function becomes undefined. So x equals negative 1 is a vertical asymptote. There is one more factor here that we need to consider. That's x plus 7. And when I set this to a 0, it gives me x equals negative 7. So this question has actually, let's just identify here, it has two vertical asymptotes. So this question, I am going to do this so I can do it faster. This question number 1, I want to find its vertical asymptote, horizontal asymptote, and I want to find its y-intercept as the question is asking me. So x equals negative 1 and x equals negative 7. These two are called vertical asymptotes. And asymptotes are always equations, so you cannot just say that negative 1 or negative 7, they are the asymptotes. Now, for horizontal asymptote, we have to actually check the degree of the numerator and degree of the denominator. So if we distribute the 14 over this parentheses, we will just get a 14x at the top. So the degree of the top is just 1, because only we have x to the first power. If we multiply everything in the bottom, the degree of the denominator is 2, because we are going to get an x squared at the bottom when we multiply them. So the degree will be a 2. Therefore, the horizontal asymptote will be always equal to y equals to 0. Whenever the degree of the denominator is greater than degree of the numerator, the horizontal asymptote is always y equals to 0. So this question has two vertical asymptotes. It has one y asymptote. The other question is asking is the y-intercept. To find the y-intercept, we must set x to be a 0. So we're just gonna, to find the y-intercept, we're just gonna plug in 0 every time we see an x. So we have a 14. Instead of x, I'm gonna plug in a 0. Here, I'm going to get 0 plus 1, and I'm going to get 0 plus 7. So that's a negative 1, so that's a negative 14 at the top. That's a 1 plus 1 times 7 is 7. When I divide them, the y-intercept is negative 2 for this question. Now for number 2, apparently there's a video we have to watch, and this is the link for the video, and the question is asking for the vertical asymptote. Instead of going through the video example, I want to just create an example here. Let's say at the top we have 2x plus 1, but at the bottom, let's say we have x squared minus 7x plus 12. Now, whenever the question asks about vertical asymptote, vertical asymptotes are always about the denominator. So we will always set the denominator to a 0 to locate the vertical asymptotes. This was a negative 7x here. So the denominator is given as x squared minus 7x plus 12. We will set this to a 0. So then we're going to factor this. Factors will be x minus 3 and x minus 4. And then these two factors will be set to 0. Then you set x minus 3 to 0. This gives you x equals 3, which will be the first vertical asymptote. And then this one, when you set it to 0, it will give you x equals 4 as a vertical asymptote. Again, the vertical asymptote is whatever the number makes your denominator is equal to 0. It might be sometimes just one number. If there's only x here, it might be two numbers. If you have x cubed in your denominator, you're going to have 3 x values, which might make your denominator equal to 0. So number 3 is the same way. So since we don't have access to video here, I am just going to create a problem on my own. So let's keep the top as 2x. It can be anything because vertical asymptote is never about this portion. But then let's keep the bottom to be 3x plus 5. And then for this rational function, if I need to find the vertical asymptote is always only related to the denominator. So I will take the denominator, set it to 0, and we just need to solve this equation for x to find the answer. I will subtract 5 from each side. I get 3x is equal to a negative 5. And then we're going to divide each side by 3. So for this question, the vertical asymptote is x equals negative 5 over 3. And then keep it in mind that asymptotes are always equations, and this is how we're going to answer these questions. And on the test, you will have questions answering about vertical asymptote and horizontal asymptote. Therefore, I want to again teach here one more time the horizontal asymptotes rule. Horizontal asymptote rules. There are 3 rules. So if you have a question like 1 over x, so if your function is 1 over x, or it might be something like x over x squared plus 1, or it might be something like 3x cubed plus 4x to the 4th minus 5. So whenever the bottom has more degree than the top, if the degree at the bottom is greater than degree at the top, your horizontal asymptote is always the same answer, which is y equals 0. This is rule number 1. You will just check the degree. So here, the degree is, you actually have x to the power of 0, which will give you just a 1. And this is x to the first power, because 1 is greater than a 0, the bottom is strong. Here, the bottom has 2, the top has 1. So the bottom has more power than the top. The bottom is here 4, the top is 3. So the bottom has more power than the top. Whenever that's the case, your answer will be always y equals 0. If you have a question like this, 2x squared minus 3, and then 4x squared plus 7. So when we look at this question, the top and the bottom, they have exactly the same degree. So if their degrees are equal to each other, then the horizontal asymptotes, they always start with y. It will be the just ratio between 2 over 4. So y equals 2 over 4, or you should just give it in simplified form. Y equals 1 over 2 will be the horizontal asymptote. So if they have the same degree, you just take the ratio between their leading coefficients. And then the last one is, if the top has more power than the top, something like this. If the top is greater than bottom, if the top has more degree than the bottom, you will have no horizontal asymptote. So for horizontal asymptotes, you have to compare the degrees at the numerator and degrees at the denominator. But for vertical asymptote, you only check the denominators, and this completes the section 5.6.